it's on here. I don't know. Never mind. A few years ago, LPW, I did a talk titled Perl and Electronics, where I talked about a set of modules I've built called Device Chip, which is all about how to use Perl talking to bits of electronics. Well, this talk is nothing to do with that. This is Perl versus electronics. This is basically a comparison of, I'm imagining people here are all Perl programmers. Probably most people here don't really know too much about what the world is like in the world of electronics, building things, working on stuff. So I thought I would just give a brief introduction, mostly showing off some photos really, of what the world is like. Here are some similarities, here are some differences, things that you might find amusing. So, well, I say a lot of you will know what I do in Perl. I look after a lot of core modules, a lot of dual life ones. I have a whole load of other CPAN modules. I've got about 158 or so of them now. I've lost count now, 150 something. I'm P. Evans on CPAN. In the electronics world, what I do is I mostly make little modules, I make test equipment, I make things. One of the main things I do is theatrical effects for amateur dramatics groups. So I build controlled lighting, controlled moving props, things that go on stage and do what they're supposed to do at the time they're supposed to do it, hopefully. And from people who might know a lot of the Perl stuff that I do, you might not be surprised to know that I spend quite a lot of time building test equipment that I need to build other things. And this becomes a common theme. A lot of the stuff that I make, I sell on this website called Tindy. Not to be confused with Tinder, by the way. Very, very different. Tindy kind of looks like this. And here's a few random things that I make and I sell. That's a piece of test equipment. That's a piece of test equipment. That's a piece of test equipment. That's a piece of test equipment that goes with that piece. There's a running theme here. So the kind of tools that we have. So over in the Perl land, pretty much everyone here will be using a text editor of some sort to write their program code. They'll have some kind of command shell, bash in a terminal or the Windows console or whatever to be kind of controlling things, running things. You'll almost certainly these days have a web browser, looking at documentation, looking at the output of your system, doing whatever. These are fairly kind of universal tools that everyone uses. You'll also have a lot of domain-specific tools, like if you work with a database, you'll have some kind of database client, or an LDAP browser, maybe. I don't know if he's still in the room. Or I don't know, whatever kind of. But you'll have a lot of tooling specific to your problem, and maybe a lot of that you'll kind of have made yourself, because inevitably you'll be working on something and you'll think, I need a tool that does this. I can't find one, I'll just make it. So you end up making tools a lot of your time. Well, in electronics, it's kind of similar. We have lots of test and measurement tools. We have tools for kind of measuring and looking at a circuit and seeing what is this device, what is this circuit doing. We have a lot of tools like power supplies, signal generators and things for throwing things into the circuit, because maybe the circuit isn't going to, the circuit isn't going to do anything unless it's powered up, right? So at least we need a power supply. Depending on what we're trying to observe it to do, we may have to throw some kind of signals into it to make it do something interesting. Especially a lot with digital electronics, you have a lot of, they don't so much have cool names, because a lot of this equipment is, some of these things maybe 100 years ago people would still have had these things, and so you get a lot of things that have established names. A lot of equipment, a lot of more modern equipment for digital stuff, industry doesn't really have nice names for it, so you just sort of name things by their product name and hope that maybe that will stick. But there's a whole category of things called active interaction devices. You have a lot of tools for building the equipment. So obviously you're going to need some kind of soldering technology, like a soldering iron. I do a lot of stuff with hot air. I'll tell you about that in a minute, because that's a fun and exciting way of making small things. You also run a lot of software as well, as I think most industries now are very heavily PC-based. So you have a lot of support software to go along with lots of hardware. Primarily I have things for doing schematic capture. So you've kind of built up your circuit, just a bunch of wires in a breadboard and so on. You want to turn that into a kind of a more formalized design, so you kind of draw a little pretty picture. and turn it into a PCB and actually get the thing made. So speaking of a huge bunch of wires, that is a huge bunch of wires. That's actually 3 different projects and a few extra bits of equipment. Can everyone see this dot, by the way? I had trouble in Amsterdam once where, for some reason, the laser pointer literally didn't work on the projector. I don't know why. But so we have here, actually, these are 3 different projects. So I've got this giant great breadboard, and I've got another one here, another one here, and another one here, and some random bits of test equipment. So I've got like a voltmeter here, and another voltmeter, and a programmer here. The programmer that I made, because, as I say, you tend to end up with a huge collection of tooling, half of which you've made yourself. So that's the kind of design, fiddling around, can we make something work end of things. Then this is the slightly more construction end of the world, where this is out in my garage. So I sort of have on the right-hand side here, I've got the soldering iron and the hot air gun over here for actually physically building stuff, and some power supplies and the other meters and the signal generator and oscilloscope and all this kind of stuff for testing. Once I've built the thing, does it actually work? So there's quite a distinction between these two, and they're both very messy. So how does the overall process, the workflow, work? So in Perl, what we're going to do is we'll start off by writing some source code. We'll write some tests for it. We'll spend some time debugging them. We might design some databases, do some kind of domain-specific stuff. We end up shipping a distribution to CPAN, or we deploy some code on some servers. And that's kind of the whole life cycle of making and finishing off something. So in the electronics, what am I going to do? Well, start off very similar, designing a circuit, fiddling around with some wires in a breadboard, make the thing work, try it out, check if it's going to work, build a prototype. Once I've got the thing working, I can draw out a PCB, and I can actually physically build the thing. So how does that look? Well, I mentioned earlier the schematic capture. So here I've drawn a nice little pretty picture of a circuit that I had on a board, and kind of captures all of the connections, what's where. You then spend a very long time playing the fun game of route the traces around and physically lay out the board as an actual physical entity. And this part usually takes hours, if not sometimes days, to just get every line in the right place. And then you send that design off to some kind of commercial company, and they build a board, and then it arrives in the post, and it looks sort of like that with a banana plug for scale. And these things arrive in the post, and then I get to physically build them. So there's lots of ways that you can physically build these. Some people work to a somewhat larger scale of components, where they are largely through-hole sized, and you can do them with a soldering iron kind of on the back of the board, and you just solder each pin individually. A lot of the stuff I make tends to be a lot smaller than this, because if I'm building things like stage props, they have to be as absolutely small as possible. And sometimes, if you've got a board that big, that's not going to work, because it's not going to fit in the prop, so you need a really small thing. So I tend to work a lot with surface mount stuff. And so for surface mount, you have this much more involved assembly process, where you typically have some solder paste, and you squeeze that through a stencil onto the board, and squish it down onto the board. And then with your pair of tweezers and your tiny little components, you hand place them all on the board, or if you're a fancy factory, you have a machine that does this, but those cost many thousands of dollars. I don't have one of those, so I just do it by hand. And then you blow hot air onto it, and it melts the solder in a process that I always like to think is much similar to sticking the toppings onto a pizza with cheese. To the point that there are maker labs that do actually use pizza ovens for solder reflow, because it's basically the same process. You take your substrate, you put your reflow cheese on the top, and then you place all of your little toppings on the top, stick them in the oven, melts them, sticks them all in, keeps them nicely stuck on there. This one is slightly harder than a pizza, because this is actually a double-sided board. So there's a fun and exciting challenge to making sure that the bottom side doesn't fall off as you're melting the top. That's always good. But, it can be done. So once we've built something, we're going to test it. So in Perl, as we've seen earlier this morning, we have a whole load of testing modules. We've got test more and things. In the electronics world, more so I think than Perl, we definitely distinguish between two kinds of testing. Because you've got your design testing. I'm fiddling around with this idea, is this going to work as a viable circuit? Does this thing do what I think it's supposed to? And then you have sort of more your implementation test, in that here I've now built my PCB, I've soldered all my components onto the board. Have I done it correctly? You know, a lot of these components, you know, maybe I put one in upside down, or maybe that leg there hasn't quite soldered on properly and it's not made a connection or whatever. So you have this distinction between the two kinds of testing. Does this design work, and have I implemented it properly? As I've said there. So here's some nice pictures of some design testing of mine. This was actually at my local Maker Lab, just because I happened to be there at the time, where I'm fiddling around with this quite small board, and I have a whole load of test wires attached to it, and I have an oscilloscope and a signal generator, and I've got my laptop that's controlling both of them from Perl, I will add. So hey, it's relevant to Perl. And some of that code might even be on CPAN. Some of it isn't yet, because oscilloscopes have... you're aware of SQL, and how SQL is this wonderful standard, and all the databases implement SQL, and so once you write your program to SQL, then you can use any database ever, right? Yeah. So around the same time as SQL, hardware manufacturers were coming up with this thing called SCPI, and the S stands for standard, because it isn't at all, and so it's horrible. But anyway, that could go on for hours, but I won't. So here's a close-up of some of the testing. All these little test clips are enormously fiddly, by the way, and you have to spend a large amount of money to get ones that don't just go ping off randomly, because that's always really annoying. So I've got there's about 8 or 9 clips on there in various places. So that's perhaps a thing that's slightly familiar again to Perl programmers, in that you've kind of built your wonderful code, and now you want to run some tests in it. And the first time you try to write some tests, you think, oh, hang on, I haven't got access to that little bit in there I could do with testing that. I'm going to have to go back and change the module a bit to design it better so that I can put the test hooks into it. Well, in electronics, we literally have things that are hook-shaped that are called test hooks, and sometimes you have to design it very carefully to make sure that you can get those physically into the right place. And this graph, I'm really proud of this graph. This is the circuit performance basically out of that. It's a filter. It attenuates different frequencies. But this curve, you look up the shape that the curve is supposed to be in a textbook, and you compare it to this curve, and it's just absolutely spot on. It's wonderful. I was very happy with that one. So our design works. How do we know we've implemented it properly? Well, we build lots of test equipment, as I said. And so this was an exciting idea I had. I had some boards that the silk screen printing, basically the little white text on the top. The fabrication company had just happened to mess up the silk screening. And so I had these spare boards left over. So I ended up building these into this little, it's called a bed of nails, where you have all of these little spiky pins that stick up that make connections onto another board. So that when you want to test it, you can connect all of your little test wires and things to that bed of nails. And then you take your real board that you're actually testing and you just push it onto there, and all those pins make a connection and connects off to all your test equipment, and you can see, does the thing work? Yes, wonderful, put the next board in. And it takes you like 3-4 seconds per board. So much nicer than using all those little test clips. If you're doing these things in volume, if you're making lots of them, you need that quickly. So there's a nice little testing thing. But how do we know our testing systems work? Well, in Perl, for example, we have test builder tester, which is useful for testing test scripts. Electronics, all of our test equipment is itself just devices that need testing, right? So we better test those. So here, for example, is, well, it's actually more development, but this was me developing and testing this device here that I made. It's called an electronic load. The electronic load I use for testing these things. This is the current probe. This is one of the things that I make and I sell. Now that current probe is itself a piece of test equipment that I was testing. Now that piece of test equipment I was using for testing some of the stage equipment that I make. And in particular, I was testing the battery consumption of this radio remote that gets used as part of this stage control system, basically, that runs this puppetry show that I run every year. And this, it's really hard to take photos of these things because the lighting just doesn't work very well for camera. So this was about the best one I managed to come up with. But this is supposed to be a Star Trek set. And in the backdrop here, there's about 100 or so little tiny LEDs that just blink and make little flashy patterns. And I had a lot of fun just watching Star Trek episodes and then coming up with, yeah, that looks like a pretty pattern. I'll make it do that. So it got very distracting during the show. You just sit and watch the flashy lights. But, I did like that one. So that's the kind of stack of making something to make something else that, again, perhaps Perl programmers are probably familiar with. So debugging things. So in Perl, we've got debug tools. We can print to standard error. There might be other debug tools. I don't know if anyone's ever used them. In electronics, funnily enough, it turns out we do that a lot as well. The so-called debugging by LED. And maybe we have other tools that we can point at if that doesn't quite work. So here's an example of debug by LED. I have this little board. It's kind of doing some things. And I have just my little set of test LEDs. And I make the LEDs flash at the right times. And turns out a lot of electronics tends to run quite fast. And so maybe it's far too fast for human observation. So I have to attach a piece of test equipment. There's a running theme here. So here's a piece of test equipment attached to it. And we can watch these signals kind of going along at high speed here, and we can kind of zoom in. We can zoom in. I mean, this is what, 20 microseconds here between these two points. So this kind of gives you an idea of the speed that the thing is running at. And for example, here's one of our LED signals. So sometimes you do need quite fancy equipment to see down at that time detail. Since we've only got 5 minutes, I think I'll skip this very briefly. If we're making something in Perl, we have a specification, and we can kind of see, does this thing meet the specification? Electronics is a bit harder. If you, for example, want to measure that something is 5 volts, how do you know it's 5 volts? Well, my voltmeter says it's 5 volts. Yes, but how do I know my voltmeter is correct? Well, I checked it with my reference, my 5-volt reference here, but how do you know that's correct? And so you sort of have this upward tree called the UK Accreditation Standard, UCAS. And basically, they give you certificates that say, we've measured it with our fancy equipment that is ultimately traceable all the way up to the National Physical Laboratory, and everyone kind of agrees, yeah, these values are right. I'm going to skip all of this because we are kind of way over time. Forwards. So the central point that I was trying to make was that both with computer programming and with electronics, a lot of the equipment and the tools that you're working with are made of the same kinds of things that you yourself are making. So what that means is that you can maintain and improve all of your own tooling. You can also make your own tooling. And that's really kind of the core of my distinction here, is that these two worlds look quite different to start with. But this, I think, is a very central concept that actually they're quite unique. They're quite unique to electronics, computer programming, like in a way that, for example, cookery, like most cooking equipment is not made of food, and so cooks or chefs or dressmakers or tailors or any of these lot don't have that same ability to build and maintain their own tools that we do in computer programming and also in electronics. So I'm going to save a minute or so for questions, and I will stop there. Thank you.